I want to thank the organizers for inviting me. I'm really not a part of this community. I think that'll be apparent from my talk. I'm really coming at this from the hypersonics perspective. But I think it's pretty important for people here in this community to think about it. This community, as I say, I'm not in it, but I get the impression that you hope to fly 10 to 30 flights, sounding rocket flights, maybe 10 to 30 balloon flights a year. What would you think about flying 1,000,000 flights a year? Well, the impetus for that would be really the commercial sector. I flew here on an airliner. A lot of people here fly airliners a lot. Airliners have been doing pretty much the same thing for about 50 years now. They fly at 20 to 40,000 feet or so. What if those airliners were flying through the mesosphere? If they were doing that, they would need the kind of weather knowledge and forecasting that is associated now with the 20 to 40,000 foot altitudes. You'd have to know that about the altitudes between 100 and 300,000 feet, because that's where the hypersonic airliners would be flying. And I think that is the future. What I'm going to talk about today is a technology that I hope and believe will break through the ice and make hypersonics affordable for all of us in the real world, not just the military world. What I'm going to do today is talk about information about, well, how would that happen? What is the technology that would make that happen? What are the implications of that for this community? And then briefly, what are the implications of that for commercial hypersonics? Which, if commercial hypersonics happen, if we get a commercial hypersonic airliner flying around millions of times a year, the mesosphere will certainly be in the center of the whole world's interest. Today, as I mentioned, you know better than I, it's done with sounding rockets in the main part of it, at the lower fringe with balloons. The potential soon is, I believe, upcoming. There's going to be a revolution in the access to hypersonic flight to altitudes of 200 kilometers or so, and altitudes through the mesosphere and above, and to Mach numbers of at least 8 to 10 and maybe 10 to 15 with a very, very low cost technology. What is this technology? It's basically a light gas gun. Light gas guns have been used in research for decades by scientists trying to get to Mach numbers of 5 to 20 or 30. NASA routinely uses this to simulate micrometeoroid impacts. The problem is that the technology has been the same for about 50 years, and it's a two-stage light gas gun that uses a first stage of a conventional gunpowder gun to launch a piston into a hydrogen chamber that compresses the hydrogen, heats it, blows a burst disk, and launches the payload. The problem with that is that process takes at least a couple of days or maybe even a week to repeat. And that means it's slow and it's somewhat expensive. This new technology basically just uses a heated steel tank. You just basically rapidly throw a slug of liquid hydrogen into the tank, it heats up, gets hot, pressurizes the tank, blows the burst disk, and the payload goes on its way. The reason that's an advantage is you can design that like a machine gun. You can fire that as frequently as you want, and it can be very, very cheap. The flip side, the downside, is that you can't get up to the Mach 20, Mach 30 regime that a lot of people use. You can only get to about Mach 8, 10, maybe 12 or 14 later on. But even that velocity is very interesting because those velocities get you up to 200 kilometers altitudes. And this will, I believe, blow open the door to affordable hypersonic development by both the military and airline companies. Why is this? Well, commercial investors are driven by economics. They're always looking at the money equation. The problem with the supersonic Concorde was that, yes, it was 2 or 3 times as fast as airliners, but it was far more expensive. Hypersonic aircraft are believed to be, so astronomically expensive that airline companies wouldn't even consider going after them. But with a low-cost way to do testing and development in the Mach 8, 10, 12, 14 range, I believe the commercial investors will get involved with this. And this is an experiment that we're going to pursue at University of California in San Diego to see if we can get interest in the commercial development of this. The way this would take place is that the commercial investors would build the technology into a development system that would then offer the launches as a service. It would offer the hypersonic testing as a service and the data from that testing as a service to both commercial people and to the government. The first demonstrations, I believe, can be in 2027. At Mach 8, as I said, the goal would be to launch 10 times per hour with very, very low recurring costs. I think the goal initially would be to get the launches below 10,000, but I think they'll pretty quickly drop below $1,000 per launch. Then if that occurs, the 2028, 2030 timeframe would be, I think, a rapid development. There would be a lot of investment by the commercial airline developers. And I think especially the military would want to push the launch rates way up. These initially would look like guns and would have fairly high acceleration loads on the vehicles up in the thousands of Gs range, but the technology can be scaled down to 60 Gs. It's just a matter of building the launch tube a lot longer. And ultimately, I think that can get down to about 60 Gs, which would be, comparable to today's sounding rockets. Unlike today's light gas guns, this technology would not be limited in scale size. You could launch a Boeing 747 size payload out of one of these launchers. You wouldn't want to do that because that would cost billions of dollars to build the launch system and there wouldn't be that big a demand for it. But certainly thousands of kilograms can be done. We've done scaling to show that you can build things up to, like 5 meters in diameter and tens of thousands of kilograms. Mach 8 is the entry point. That's easy to do. Mach 10 to 12, though, is probably certainly feasible with some more development. So a commercial service plan, what would that look like? It might look like the vehicle that's in the picture here is about this long. The first commercial thing would be something a little bit larger than that. The payload would be maybe in the 8 to 10 kilogram range, about 4 liters volume. The vehicles would be a turnkey thing that would be provided by the commercial people who are providing this service. And it would have a fairly sophisticated GPS inertial guidance system and control system to give the user, the leaser or renter of the service a pretty high quality control of the trajectory. For this service, I think the pricing would probably start at about $10,000 per flight. So what could be done with this in atmospheric R&D? Well, one of the most important things, as I said at the beginning, is that if people really want to develop hypersonic airliners that fly between 40 kilometers and 60 or 80 kilometers in altitude in the mesosphere, they're going to want to know a lot more about what is happening there, not only from sort of a constant basis, but on a minute-by-minute basis. You don't get into an airliner and fly from one city to the next without knowing what's happening in the weather at 20 to 40,000 feet as that flight is going. And the hypersonic airliners are going to need the same thing. They're going to need real-time data about what is actually happening at this moment in the mesosphere along that flight path. And that is something that, is absolutely impossible today, but will need to happen. And if these hypersonic airliners are developed, they will basically fund that kind of capability to be developed. So what about, why have hypersonic airliners? Well, I don't know. I've traveled to Japan a number of times, and to South Korea and to Australia, and it is a trek. It's very painful. If I could get to Japan, to China, to South Korea, to Australia in 90 minutes, I would love that. You might ask, well, what about the cost? It turns out that aerodynamically, once it's sort of like getting up on top of the plane when you're in a speedboat. If you get up to a high enough velocity that you can kind of surf at the top of the atmosphere, the fuel costs actually start coming down. And it's possible, maybe, I'm not sure, I'm not a good enough aerodynamicist, but I think it's conceivable that the total energy consumption of hypersonic airliners could be comparable to that of today's airliners, maybe even lower. And it's also true that if you're going to be going up there, hydrogen is going to be the only fuel that you're really going to want to use. So there's not going to be any carbon emissions from it either. So I think this could create a $1 trillion economic opportunity for the world that would generate a tremendous pull for the type of knowledge and research and data that the people in this room are, have been concerned about in their career.
Certainly a very interesting idea.